Good morning, Year 5s. It is Friday, which means we've nearly got to the end of another week. And hopefully it's starting to feel a little normal and maybe a little bit more manageable. Maybe you got yourself in a routine, perhaps. But anyway, let's have a look at our maths do now for Friday. So we'll do that. Let's just shuffle that forward a bit. There we go. So, prime factors of 90. Ooh, well, I know that you can make 90 with 9 times 10. I know that neither of those are prime. I'm going to have to go awkwardly sideways here. Ugh. 3 times 3 is 9. They're now prime. 10. 5 times 2. They're both prime. So just because you get a bigger number, I'm not giving you the 20 or 25. Use times tables. 90. Ooh, well, it's just in the tens, isn't it? So 3 times 3 times 5 times 2. Beautiful. 2 factor pairs of 44. I only want 2. So remember what we said the other day? If you only need 2 factor pairs of a number, and it's even, well, let's just cheat. 1 and 44, 2 and 22. You could even have 4 and 11 with that one, couldn't you? But you don't need to do the entire factor frisbee. So if it asks for 2 factor pairs and it's even, go for 1 and 2. I'm thinking of my answer is 345. I had 15, so let's take away 15. 330. I had another 14, so let's take away another 14, which is 316. 360, and then I halve it. Well, so let's double it. And you might just want to check that one on the side. There's nothing wrong with that. It's not like as you get older you don't suddenly do your calculations. 2, 33, 6. There you go. 6, 3, 2. There you go. Now the middle one, I tried to mix it up a bit for Friday for you. So I put, can you create your own missing angle problems? Now the only way you're going to be able to check that is giving it to an older brother or sister who should be able to do these, or a parent when they've got some time after maybe they've done their work, and see how they do. So like I've said, one involving a triangle. So that might be a certain angle. That could be a certain one. So it could be something like an isosceles, and you put the equal sides there, and you give them, maybe you give them that one and that one, or maybe you just give them the top one, and then they have to divide. Maybe you give them a triangle question that's on a straight line, and you give them this one here. Maybe say that's 120. So what's this one here? Well, that's more of a straight line one, isn't it? Maybe what's that one and that one? It's completely up to you. Try a few out, see which one you want to do, or have a look back and see what sort of angle questions have been, and nick one. The straight line one, again, you could go very simple. You could just make a straight line one like that, or you could have something that intersects on a straight line. You could give yourself a 90 degree, and that is still technically on a straight line that you're working with there. Or you could give them a quadrilateral, you draw a 4-sided shape, and you give them some of the angles. It's completely up to you how you do it. But it'd be interesting to see if you could, because if you can create your own, it shows that you understand the concept. Okay? So don't just draw a line and go, oh, this one's 160. Have a go. Really try and make one work. And if it works, well done. 67 times 1,000. Well, there's 3 zeros, so let's get our 3 zeros there. That looks strange when I did that then. 67,000. 23.75 divided by 100. Well, there's 2 zeros, so 1, 2, so that becomes 0.2375. And then times this one by 100, so we've got only 2. So move it one place would be that, move it another place, we'd get a 0. So that's 12. There's a large number of answers today. But lovely. There you go. On to our questions. So, I thought to finish off the area and perimeter theme that we'd had for all of this week, most of this week, all of this week, I'll give you some worded problems, because you look at these and you don't instantly know that these are area and perimeter until you read the question. Whereas when you get football pitches and measurements down the side, you tend to know, oh, okay, I'm doing area and perimeter here. Oh, I've not shown you my mug. I've shown you my mugs before, haven't I? This is my mug, busted mug So a couple of years ago, I went to go see McBusted live, a combination of McFly and Busted, and I purchased a mug. It's quite a nice one. It's not a bad one. Anyway, so first one, I'll go back down to here. So the first one says a square-shaped room measures 6.5 feet on one side. What's the area of the room? Now your first thought for this one might be, oh my goodness gracious, we've not done feet. I've put those questions in on purpose because it doesn't really matter what the unit of measure is for these. It could be 6.5 bananas. What's the area of the room in bananas? It doesn't particularly matter. It's just a measurement that you're using. So a square. The key here is a square-shaped room. Tell you what, if we're doing word problems, let's look at the word problems. So the key here is it's a square-shaped room. Because if you know it measures 6.5 on one side, it's going to measure 6.5 on all four sides because it's square. So what's the area of the room? Well, we can just do 6.5 times 6.5, can't we? Because, let's do this one very tiny. If that was a square, one side is 6.5, well they're all going to be 6.5 because it's a square. So how do we find the area? Well, we do length times width. So 6.5 times 6.5. Don't forget, when we're using decimals, ignore them for now. So 5 times 5 is 25. 6 times 5 is 30. Add 2 is 32. We're done with that 5. 0 the hero. Now we're doing this. 6 times 5 is 30. 6 times 6 is 36. Add 3. Should be 39. Let me just point out, if you're not getting your times tables that quickly, get yourselves on Timetables Rockstars. End of year 5 now, your times tables should be facts. So, add them up. 5, 2, 12, 4. Okay, now, the final thing, we've got our decimal points. Now, in this question, we've got 1, 2. We've got 2 digits after our decimal. So, bit of a cheat. There you go, there's your answer. Oh, and don't forget, it's in feet. Not that we've ever done feet yet. That's for year 6 when you look at imperial measurements. So there's your answer. It should be square feet. So 42.25 is your answer for that one. Very simple. It was nothing in there should have thrown you other than me being mean and giving you a foot question rather than meters. The next one is number 2. A rectangular field measures 10 feet by 3.5 feet. What's the area of this field? Well, again, we've got lovely simple shapes going on here. The key is it's a rectangle. It measures 10 foot by 3.5 foot. What's the area of this field? Now, some of you might be going, right, okay, I'll draw this out again. Do you need to? If you're times in length times width, what I've been practicing all week over here, times by 10,000. This is exactly when you need to use it. So 10 times 3.5 is going to become 35. 35 square feet. Seconds that one takes. You can always check it. Feel free to check it, but we've been doing that. That's exactly why we do it. Right, next one. Sorry, it's a bit far away. Danny has a rectangular rose garden that measures 8 metres by 12.5. One bag of fertiliser can cover 16 metres squared. How many bags will need to cover the entire garden? Whoa, right, okay. First of all, let's find the area of the garden. So what's his garden? 8 by 12.5. Okay, so 8 metres by 12.5 metres. Okay, here we go. So we need to know his area of the garden first, don't we? Just like we've been doing. 12.5 times 8. Forget the decimal for now. We'll come to that in a minute. 8 times 5 is 40. 2 times 8 is 16. Add 4 is 20. 1 times 8 is 8. Add 2 is 10. Well, that's a nice number, isn't it? You've got one number after your decimal. That one's not after the decimal. There's no decimal here. It's just the one that the number's in. So there's a digit after the decimal. So it's there. So he's got 100 metres. So his rose garden is 100 square metres. A bag of fertiliser covers 16 square metres. How many bags do you need to cover the entire garden? So you need to now find out how many 16s go into 100. Okay? So your question is, how many 16s do go into 100? So that's your final part. Work it out. You can either go up in 16s. You can write. I know a few of you just do a couple of 16s. To be fair, that's not a bad idea. 6, 12, 18, 24. 1, 2, 3, 4, 5, 6. Oh, we've got to 64. Get another couple of 16s on there, and find how many bags. 1, 2. That was 4 bags. How many do you need to get to 100? Remember, if it goes over 100, that's okay. If it's under 100, he needs another bag. Okay. But again, the actual area problem should be pretty simple for you. We start to get even tastier now. Each table in a classroom is 110 centimetres long and 55 centimetres wide. I do believe that is true. What is the area of each table in square centimetres and metres? So, first of all, we've got 110 by 55. So first of all, let's find the area of this. 0 times 5 is 0, 1 times 5 is 5, 1 times 5 is 5. Nice and easy. 0 times 5, 0 here, nearly forgot. 0 times 5 is 0, 1 times 5 is 5, 1 times 5 is 5. What a nice easy problem that was. 0, 5, 10, 6. There we go. So, the area of the table in centimetres, which is your first answer, is 6,050. It also wants the area in metres. Now, don't forget, you've got your conversion thing chart on a couple of pages back. I think it was on Mondays, wasn't it? But some of you should be able to remember, if there's 100 centimetres in a metre, then we divide this by 100. So it should be 60.5. There you go. So now we've got that, let's have a look at our question again. So, what is the area of each table in centimetres squared and square metres? So we've done that half now. There are our first two answers. There are 16 tables in a classroom. What is the total area of the tables in metres squared? So, now that you know that 1 is 60.5 metres squared, you need 16. Hang on a minute. I know what we're going to end up doing here. That's almost not quite in line, isn't it? And you do the same again. So 6 times 5 is 30. No 6 is nothing. Add 3. 6 times 6 is 36. Done with the 6. 0 the hero. 5, 0, 6. Add it up. 0, 5, 6, 7, 8. 9. But then we've got one number after the one digit after the decimal. So there you go. 968 metres squared if you put all 16 tables together. Bob's your uncle. Unless he's not. And then I think we've got one. Oh yes, we've got a couple more here. I'm going to say that if you've got those answers, then you should be able to answer these ones. I'm just aware of the length of the video here. A window, I'm just going to talk through the last two. A window is 1.7 metres wide and 85 centimetres high. What is the area of the window? Right, well that's the first thing we've got to do then, because there's a question there. So instantly you're going to do 85 times 1.7. So get your column in. And you should have a decimal place with one, you should have one decimal place answer there. 3 times the area of the window is needed for the curtain. What's the area of material needed? So whatever this answer is, times by 3. These word problems, they may look hard, but actually they're all just multiplications. They're all just find the area. Right, now you need 4 of them, or now you need 5 of them. A field of wheat. I like this one. I think this might be my favourite one. A field of wheat measures 150 metres by 82 metres. What's the area of the field? Boom, 115 times 82. A combine harvester harvests the field in 45 minutes. How many square metres does the combine harvester harvest each minute? So what you've got to do there is you've got to divide the area of the field by 45. and you will find how many square meters he does in a minute. Okay, so if you, I totally know that some of us won't have a look at that challenge. That's fine. For those who do, hopefully, you found the area there, and you divide it by the 45 minutes that it took to do it. So brilliant. That's this week's math sorted. Next week is already sorted and planned. It's not up yet, but it's going to be looking at comparing decimals, fractions, and percentages again. So don't forget, no calculating between them. We're not technically converting it. We're knowing the pattern. Okay. So if it says that it's 0.6, we know it's also 60 hundredths and 6 tenths. It's just, we know that. There's no calculating. And then towards the end of the week, we start looking at Roman numerals, which I absolutely love. But enjoy your weekends and have a well-earned rest. And hopefully, make sure you do something at the weekend that makes it the weekend. And I'll see you on Monday.